Review sheet. Oh, yeah, I know it's happening. Just a minute. Okay. Okay. Yes. Well, you have a test. You mean in addition to get ready for your test?
Oh, I meant, studying is the only homework?
Yeah.
Okay.
Yeah. Yeah, nothing new. F of x would be 7x minus 9. G of x is 2x minus 4. And they want all that. Let's just do them all. Now that Colton is making me do it.
How long was division?
Well, now I'm doing it all. This is happening. It's all happening. You started this. Now you're going to finish it. That's a parent thing to say right there. Okay, so we're adding the f plus the g. Combine your like terms. You get 9x minus 13. Do you agree, Colton? 9x, okay, so now let's subtraction. Okay, I do want it. This is good reminders. Nothing wrong with what's happening right now. Just remember subtraction. You have to distribute that subtraction to both. So remember that. That's really the only thing people miss with subtraction. Both of those second things are getting subtracted. So that gives you 7x minus 9 minus 2x, but then plus 4. So your final answer there is 5x minus 5. So that's your f minus g. F times g, you're going to FOIL. So put those two parentheses next to each other and multiply. You go there. Oh, Colton, I'm complaining about you on the video, I just realized. Now you can listen to it. Anybody saw? You guys are saw. Is Danny McBride the girls' assistant coach or the guys?
Girls.
Girl, anyway.
I don't think he works there.
Oh, is he guy? That's right. He's in Florida. Anyway, when I taught Danny years ago, I was doing this and I kept talking about foil, and he said, "You mean lobster claw?" I was like, "Excuse, what?" He's like, "It's lobster claw. It's lobster claw," and I could not see it. And then it's because when you do those arrows, it looks like a big claw. Like here's the little claw. Anyway, so now that's all I can see. I curse him for it. But I guess in Scotland, if you go and you get into a conversation about foil, please know that lobster claw is the correct mathematical term for that. It's good times. So you're multiplying everybody. 7x times 2x is 14x squared. 7x times negative 4 is negative 28. Negative 9 times 2 is negative 18. And then negative 9 and negative 6 is positive 36. You can then combine those middle ones. 14x squared minus 46x. And I will make sure all your answers are posted. So if you're writing furiously, all these will be available to you. And now, f divided by g. Whoop. We'll do that in green. Okay. So if they want f divided by g, put the f function in the numerator and the g function in the denominator, and then reduce if you can. But on this problem, I can't reduce because I can't factor the top. There's nothing that they have in common. I can't take an x out. I can't take a 2 or a 3. And there's nothing in the bottom. Well, actually, I can factor a 2 out, but that's not going to help me because there's nothing to cancel with. I cannot cancel these x's. And the reason is because you have subtraction here and here, and that binds these two terms together. And you either have to cancel the whole thing or nothing at all. So you can't cancel those x's. So that's it. That's just your answer. That's all I have to say about that. But let's do 8, just the division. Let's do 8, just the division. Because that second one,
Is it division?
oh, it doesn't even ask that. Well,
Can you do 8 still though?
Yes, 8, that is a good idea. I feel that that is a good use of our time. 4x squared, yeah. X squared minus 5x. Okay, so this time they want numbers. They want f minus g of negative 1. And we didn't do too much practice on this, if I remember. So it's probably a little rusty. Okay, I have two options. Two options. You can either do f minus g of x and get your answer in terms of x, and then plug negative 1 in for x. That's option number 1. Or you can find f of negative 1, g of negative 1, and then subtract them. I don't care what you do. We'll just do both since we're practicing, and then you can decide. So I'm going to do f minus g in terms of x's. Is somebody stopping me? No, I'm recording too. So I'm going to do it in terms of x's. So I've got f, 4x squared minus 7, minus g. Notice how I put that g function into parentheses so that I don't forget to distribute. If you don't put those parentheses, you're going to get it wrong. So make sure when you're subtracting, put that second one in parentheses. Distribute that negative plus 5x. That gives me 3, because I have 4x. This is 1x squared right there. 4x minus 1 leaves me with 3x squared. Then I have my 5x, and then I have my negative 7. So I can do f minus g of x and then plug in negative 1 for x. That's option number 1. So if I want f minus g of negative 1, I got to plug negative 1 in right there and right there. Be careful with your order of operations. You have to do the squared first. Don't multiply by 3 first. Do the squared. That's that order of operations. Negative 1 times itself is positive 1. Negative 1 times negative 1 is positive 1. So I have 3 times 1, which is 3, minus 5 minus 7, which is negative 9. So that's my answer. That's method number 1. So I did it f minus g just in terms of x's. So I did all the work with the x's, got to my final answer, and then plugged in negative 1. That's option number 1. Option number 2. Go up here to the top. Let me erase. Find f of negative 1, and then g of negative 1, and subtract those two values. That's option number 2. So I could plug in a negative 1 right up here. Does that show up on your screen? Yeah. Negative 1 squared is 1. 4 times 1 is 4. And I get negative 3 for that one. Then I'm going to plug in negative 1 into that g function for x. And I get 1 plus 5, which is, So I did something wrong. No, I didn't. I don't need you people. So I have, let's circle in red. We're getting confusing. My g function, when I plugged in negative 1, was 6. My f function, when I plugged in negative 1, I got negative 3. And now when I do f minus g, here's my f answer minus my g answer. And I get the same thing I got below. I think the top one is faster for this problem. That's not always the case. But either one is fine. Either one is correct. So either plug negative 1 into both functions and then subtract your answers, or get f minus g in terms of x's and then plug negative 1 in at the end. Same thing is true for f times g. We might as well do the shortcut way. That's the nice thing about this, is once you've evaluated what f of negative 1 is and g of negative 1, this becomes very fast. I don't have to, all I have to do is multiply these two together. So that's negative 18, boom. That's nice. So that method is helpful if you have more than one thing to do with those functions. Just evaluate each one for -1. Once you have those answers, just do what it tells you to. In this case, it tells me to multiply them together. So I do -3 times 6 gives me -18. That's the answer to that one. Boy, if you floated away and just came to, because we didn't fall, like we're all over the place. There's no, oh well. So number 11, we have f is x squared plus 2x minus 2. The g, x squared minus 2x minus 5. And what they want from us is f of g of -1. What's with all the negative ones? They like it. My -1 is cute. It's got a little tail on it. Whoop. As usual, that did not make it better. Someday. There we go. Okay, there is a good way and a bad way to do it. The bad way is gross. The good way is ungross. I do not recommend, unlike the last problem, that you use the option of finding f of g of x and then at the very end plugging in your numbers, because that would involve picking this up and plugging that whole thing into this and having to square it and then plugging it in there, and that's gross. So when it's f of g, here's how it looks with your numbers. You start with the letter closest, as always, which is g, and you plug -1 in for just the g function. So I get -1 squared minus 2 times -1. -1 squared is +1. -2 times -1 is +2 minus 5. That's my halfway answer. Halfway. I plug -1 into g, and then remember f of g wants you to take this and plug it into the other one. So -2 is what we're now plugging into the f function. So it's -2 squared plus 2 times -2. -2 squared is +4. Then it looks like we have -4. 4 minus 4 minus 2 is -2. So that's our final answer. Look, that's funky. Our final answer is the same as our halfway answer. Creepy. Doing it the other way, it just, nope, not good. So f of g, or g of f, you plug the number into whichever one is closest to it first. Get your halfway number. Hello, you see that? So close. And then you take your halfway number and plug it into the other function. Make sure you do me this favor. Don't circle both, because then sometimes students think there are two answers and they're not sure. So if you circle both, I will assume you're in that category. So make sure, or if you happen to circle this out of habit and note keeping so that you point it out, make sure something, like if you gotta, hey, this is it right here, this is, whatever you have to do so that I know what the one true answer is, I would go ahead and do that. I just want to do the arrows because I find them enjoyable. So there's only one answer. Make sure I know which one it is. So that's how to do f of g.
What is 14?
14, yes. That is a great idea. 12 is the same way, just reversed. Don't let that fraction in 12 skip. We better do 12. Let's do 12 in the middle of 14. I want only because I think people get a little weird. I'm getting bored of these colors. Purple, that's inspirational. And yellow. Oh boy. It's like going to the spa. Look at that. It's like cucumber water right here in class. It's refreshing. It's kind of upscale. Nobody's with me on this, are they? Nope. Nobody's with me. Okay, what they want here is g of f of 10. And I wanted to do this one because of what you get halfway. So you start with what's closest to the number. F is closest. So I'm going to plug 10 into the f function. 10. What is with the minus 4 over 5? And I get 6/5. This is where a lot of people go, I'm not doing the rest of that problem. I know. I see it. I know it. I know. This is not my first time teaching this class. But don't stop. Don't say, oh my gosh, I hate that. It's okay. That's your halfway number. I circled it, so I'm going to make sure to double circle my answer. That's my halfway answer. Don't make it 1 1/5. That's gross. Don't make it a decimal. Leave it 6/5. Now we have to plug that into the g function. It's going to be okay because we have 5 times 6/5 plus 4. Remember, that's 5 over 1. I have a 5 in the top. A 5, and there you go. Yeah, so that's nice. See? It's like adolescence. If you just wait a little bit longer, sometimes it's a little rough for a while, but then a blossoming flower. Some of you are education people. That's how it is. So 10. Notice, look what happened. What we plugged in the beginning, we got back out. Look at these two. What are they? Inverses of each other. And I could tell that kind of by doing a quick glance. I had minus 4 and then plus 4. I had divided by 5 and then times 5. And it's in the correct order. So it just happened. They happened to be inverses. It's kind of a good time. All right. You don't like the cubes? No. Okay. Cube root of x minus 4. That's g of x. Oh, we're getting sassy. Now we have g and h of x. And are you testing? Yes. So the test is f of g and then g of f. So we pick up that g function and we plug it into, oh, look, I'm sorry. I put f of g and there's no, boy. Okay. I'm sorry, everybody. Sorry. So yeah, see these, you can eyeball those and see they might just be inverses. The only thing you have to be careful of is not only do the operations have to be opposite, but their order. It's like this is a set. Can I write on this? No. Like I could. Good. So like I could have this. I know what I'm trying to say. I'm like, I can't get it out. So I could have that and then this. And technically, that's opposite operations from this. So it's not just that the operations have to be opposite. It's the order that you do them has to be opposite as well. So just be careful with that shortcut. Like these, you might say, oh, I had minus 4, now I have plus. I had cube root, and now I have cube. But this is not an inverse of that. So this one is, but we don't know that. Okay, that was just a little, sorry. We'll just go back to what you already know. That was just an interesting tidbit. All right, so we're doing g of h because they changed letters on us. And by they, I guess I mean me. H of g. Hog. Okay, we're picking up the h function and plugging it into the g, and it's going to look like this. We have our cube root. That's the g function. Instead of the letter x, we're going to put this whole thing, x cubed plus 4. That's what it looks like. The plus 4 and minus 4 cancel. And then cube root and cubing are opposite operations, and they cancel, and you just get x. Now when we do the hog, you take the g function, pick it up, and plug it in right there. So we're going to do some parentheses here. It'll look like this. Cube root of x minus 4. That whole thing is being cubed. And then plus 4. Well, again, cube root and cubing are opposite operations, so they cancel. And what was inside just falls out. And now those 4's cancel. So I know that I have inverses here. Inverses. Check, check.
Can you do 18?
18. Yep. I tell you what, let's do one where we have to find the inverse.
I like that.
15, 16, 17, and then we'll definitely do.
Well,
Any preference?
17.
17? Boy, it is. You know why? Color change time. Let's go orange. I try to get UT orange. Not because I like them, just because responsive.
Yeah.
Oh, you can't tell the colors on there. Oh. Okay, this time I have to find the inverse. Step 1, replace f of x with the letter variable y. Step 2, change places with the x and y. Is it just a dog? Sometimes it sounds like a... Then you're trying to get y by itself. You have 2 things to get rid of to get y by itself. You got to get rid of that 8, and you got to get rid of that radical. That 8 is trapped inside the radical. That radical is actually an exponent, so we have to get rid of it. The opposite of square root. I know it's a square root because there's no number right here.
Parentheses squared.
Yes, so you do parentheses squared. That's the opposite of square root. Make sure you do that to both sides. So that cancels out my radical. I have x squared equals y plus 8. And now subtract 8. So your inverse is x squared minus 8. That's your inverse. Okay, 18 and 19, here's what that's about. You're going to create the inverse. You're going to graph both of those, both the original function and the other, and then show on your graph how you can tell on the graph that they're inverses. Probably on this whole test. So let's do 18. Here's what it looks like. And these are doozies. I mean, there's a lot going on here. They will be worth a lot of points because there's a lot of work involved, so you should get credit for that work. First thing that I know how to graph that. That's helpful. I thought the dog was bad. Now I got to, the paper towel, the dog, and now that. I'm going to graph that. I know what it looks like. It's a parabola. It's over here 4 places. Okay, there's that. Now I've got to create the inverse to it. So I'm going to go over here and do my inverse steps. Y equals x minus 4 squared. Switch places with your x and your y. That looks like that y and that 4 look the same. Yeah. Now I want y by itself. The 4 is trapped in parentheses. I got to get rid of that squared. Square root of both sides. So I have square root of x. That radical cancels out. And I have y minus 4 left. What was inside comes out. Now I have to add that 4. Did I do something weird? Not that you know of. So I had to take the square root to get rid of that squared symbol. Square root of both sides. add your 4. Now I want to graph that. And so my advice is, we've never graphed it with that y on that side. Just switch sides with those two. And that 4 is not underneath that radical. It's not part of the radical. Remember, it was not over there when you took the square root, so it doesn't get to go inside. And to graph that, we go up 4 places. And that's this graph. So at first glance, you might say, that looks like a big ball of nothing. Right? That looks like a big chunk of nothing. That just looks gross. But they are reflective, and the problem is they're not reflective until we get to about here. Like, this is not a mirror image of this. Remember, the goal line that we want them to reflect on is this 45-degree angle right there. Now, if I continued this green parabola out, it's easier to see that reflection. You see it? If my black line is off, but you can see how this is reflected from that side. If I make this, I'll make that better.
How could we explain that? Can we just draw a line?
You're going to draw the line. Okay, so yeah, you'll draw that reflective line, which is that 45-degree angle, y equals x. I want to see reflection, but then you have to explain this. Like, it's reflective up here, and it's reflective until you get to right here. The explanation there is because we have a domain issue. That's not the. So technically, it's like reflective from here. Wait. Does it say find the domain?
No.
It does. Okay. Well, it's greater than or equal to 0. Is this, which is right here. That's all real numbers. There's no radical. There's no fraction. This one, you take what's inside, set it greater than or equal to 0. So here's where x is 0. You know, really, we don't want this half of it. They generally draw like a diagonal from this point to this point, you're 0. But that doesn't explain that little thing there. I don't like that being there. Maybe they do it from here. Yeah, like this one's all real numbers is the domain. Because your only time you're limited is if you have a fraction or a square root. Like here we have a square root. So I can't put -1 in for x into that one because it won't work. So it doesn't exist back there. So it's really only reflective from that 0 diagonal, since we're on a diagonal. The reflection starts from here up. But that's sort of hard to explain. There's not a good explanation. It just is what it is. So I would say to you, do me something like this. Show me that it's reflective. Reflective. Show that line. Your domain would be x has to be greater than or equal to 0. So from here, from here on the diagonal, which is what we're following, from 0 up is where it's reflective.
So basically, if you pull that point off of the positive 4 down there on the bottom, and you attached it to the 45-degree, that's what you're showing the reflective.
Yeah.
This angle right
Yeah.
here.
Yeah. But they should mirror image each other. And so, like, again, I had to extend this up. See how originally I had my arrow there? So I had to extend it up so that I could see that reflection a little bit better. So you might have to do that. Let's just do 19. Because you haven't graphed a linear probably in forever. The inverse is easy on 19. You're not going to have any problems with that. The graph might give you some issues. That's my function. I'll go ahead and get the inverse. So I switch places with the x and the y. I'm going to get y by itself. First thing I do is get rid of the 5. That leaves me with x plus 5 equals 4y. Divide by your 4. Oh, I tell you what, I'm not going to give you this on the test. Yeah, because what you have to do is that you have to, in order to graph that, you'd have to say, well, that's x over, you'd have to split that 4 up. And then you have 1/4 is your slope, and that's your y. We're just not going to deal with that. Okay, so just cross that out. So we'll make sure what you're graphing are the ones that you're familiar with. Okay, so I'll put the rest of the answers up that we did not go over today. Email me, come see me, particularly if what, Sarah Lamb and Tim, if I don't post these videos.